Hello everyone, welcome to the new video of preclinical pharmacology. Today we will discuss about the new topic that is xanthin oxidase, an important enzyme in a purine metabolism. Now in this video we will see in detail about xanthin oxidase. Let's see the introduction about xanthin oxidase. Xanthin oxidase plays an important role in the metabolism of purine and it has a significant physiological function in a various cellular and a metabolic process. Purines are the essential components of a nucleotides which are the blocks of a DNA and RNA. Xanthin oxidase is the center of the breakdowns of a purine of nucleotides, especially in the final step of purine catabolism. This is enzyme is an important for regulating level of uric acid in the blood. When its activity increases, it can causes a condition like a gout. When the excess production of uric acid in a joint causes pain and inflammation. Xanthin oxidase is a type of enzyme that generates reactive oxygen species. The normal range of xanthin oxidase in a human body in males is 22 to 45 unit per liter, in females 20 to 40 unit per liter, and in children 50 to 30 unit per liter. Discovery of xanthin oxidase. Xanthin oxidase are discovered by the Robert Allen Smith and Emil L. Smith in 1953 in the Institution of University of Utah, USA. Structure of xanthin oxidase. Xanthin oxidase consists 1337 amino acid. The overall shape is a globular shape with dimension. The molecular weight is 145 kilodalton each subunit. And the subunit structure as xanthin oxidase consists of two-dimensional subunits. Reaction catalyzed by xanthin oxidase. There are the two types reaction in a purine metabolism. The first one is the conversion of hypoxanthine to xanthine. In that hypoxanthine reacts with oxygen and water and then it forms xanthine and hydrogen peroxide. This is the first step in the breakdown of purines. And the second one is the conversion of xanthine to uric acid. In that, xanthine reacts with water and oxygen, then it forms uric acid and hydrogen peroxide. This is the final step in the purine degradation that producing uric acid which is excreted in urine. Types of xanthin oxidase. There are the two types of xanthin oxidase. The first one is xanthin oxidase. It mainly found in the liver and the other tissue. It has two key activities. The first one is the conversion of hypoxanthine to xanthin, and the second one is the xanthine to uric acid. The second type is the xanthine dehydrogenase. In that, this is the precursor form of xanthin oxidase, which has a similar enzymatic functions but used as a NAD plus as a cofactor instead of a molecular oxygen. Xanthin oxidase mechanism. In that, hypoxanthine or xanthin binds to the active site, then electron are transfer. The enzyme helps to move electrons from the substrate to oxygen, producing some reactive form of oxygen, then production of uric acid and the release of byproducts. In that, when the conversion of hypoxanthine to xanthin, then the both are produce hydrogen peroxide as a byproduct. Test for measuring xanthin oxidase. The first method is the spectrophotometric assay. In that, the monitoring the conversion of hypoxanthine to xanthin and then to the uric acid. The second one is the high performance liquid chromatography. In that, the separate and the qualifies the reaction product after the exocatalyst reaction. And the third one is the fluorometric assay. Utilize the substrate that produce the fluorescent signals upon the oxidation by XO. Application of xanthin oxidase. The first one is the cardiovascular disease. In that, xanthin oxidase has a protective effect on the cardiovascular system by the XO helps to keep the blood vessels healthy and improve the blood flow. The next one is the cancer. Xanthin oxidase have both positive and the negative effect in a cancer. The good role into the help the immune system. XO produce molecular cell reactive oxygen species. In the small amount of reactive oxygen species can actually fight the cancer by boosting the immune system. They might help the body recognize and attack the cancer cell, and as well as it has a also bad effect in that Cancer growth and damage. XO produce reactive ROS as a byproduct, and the large amount of ROS can damage the healthy cells and DNA. This damage can lead to the cancer to make the existing cancer growth faster. Too much ROS can make the cancer cells spread more easily. The third one is the neurodegenerative disease. In that, the condition like Parkinson disease and the Alzheimer disease, the mild level of exo-derived reactive oxygen species might play a role of promoting neuroplasticity and also modulating the neuroinflammation in a beneficial way. The next one is the liver disease. Xanthin oxidase produce reactive oxygen species RAOs during the conversion of hypoxanthine to xanthine and then to uric acid. The increased level of RAOs can contribute to oxidative stress in the progression of a liver disease, in such as a non-alcoholic fatty liver disease and alcoholic liver disease. Detoxification. Xanthin oxidase plays an important role in a detoxification in the body through the purine breakdowns, uric acid formation, and a reactive oxygen management. The next one is age-related disease. Xanthin oxidase generated reactive oxygen species during the purine metabolism. The elevated RAOS level can damage the cellular components, which can cause aging and age-related disease. The next one is wound healing. Exo produce ROS in the moderate amount of ROS, which is help to the fighting infections. The next one is the anti-inflammatory effect. Xanthin oxidase has a both positive and the negative anti-inflammatory effect. In that, inhibition of xanthin oxidase can reduce the production of ROS, which help to the lower oxidative stress and inflammation. Uric acid also have a positive effect on the moderate state, acts as an antioxidant by the promote the cells from the damage and also help to the neutralizing free radicals. The next one is diabetes. Elevated RFS level causes oxidative stress, which is damage pancreatic B cells and also contributing to insulin secretion. In GIT, in gastrointestinal tract, xanthine oxidase generate reactive oxygen species during digestion. They can help to fight infection and improve the gut health. But the too much formation of RFS can also harm from gut health and causes inflammation. Xanthin oxidase inhibition and induction. The first one is inhibitors. The inhibitors are the reduce the xanthin oxidase activity and also reduce the uric acid production. The inhibitors are including alloprenol and fibroblastates, and natural compounds are flavonoids and polyphenols. And the nutrients are present vitamin C, vitamin E, omega-3 fatty acid. The role of inhibitors are the first one is that treat gout, prevent kidney stone formation, reduce oxidative stress, and also reduce cardiovascular disease. The next one is the inducer. The role of inducer that to increases the exo activity and also increases the uric acid production. The lifestyle factors are including ethanol, high fructose diet. The pharmaceuticals are including tamoxifen and cyclophosphamide. And the nutrients are including fructose, glucose, and purine-rich food. Increases the inducer's activity can also produce the condition like gout, cancer, and the cardiovascular disease. XO increases the oxidative stress and the cardiovascular risk. Clinical implication of a xanthin oxidase. The first one is the cardiovascular disease. The protective effects of a cardiovascular system by influencing the vascular functions and exhibiting the anti-inflammatory properties. The second one is the neurological diseases. The helping to the regulating blood flow and reduces oxidative damage in the neurological condition. The next one is the diabetes. Elevated RFS level leads to oxidative stress, which is damage pancreatic B cells and impairing insulin secretion and contributing to insulin resistance in peripheral tissues. The next one is the cancer. Production of reactive oxygen species, which can causes DNA damage and mutation. And the next one is the liver disease. The high level of reactive oxygen species can damage the liver cells and leading to the inflammation and injury. future direction. The first one is a biomarker identification. In that, xanthin oxidase activity as a biomarkers for a various diseases which could help to early diagnosis and monitoring to treatment efficacy. The next one is the genetic study. In that, exploring genetic variation in xanthin oxidase gene and their association with a different disease potentially leading to the personalized medicine approach. The next one is the clinical application. In that, exploring the role of xanthin oxidase in the transplantation and ischemic injury, refusion injury, where it is a modulation could improve outcomes. And the last one is the biotechnological application. In that, utilizing xanthin oxidase in a biosensors for detecting purines or as a tools in a biocatalyst for a synthesize pharmaceuticals. Thank you.